Welcome to my channel Chemistry Not Mystery. You can also visit to my website chemistrynotmystery.com. This video is also available in Hindi and you can get its link in the description box. So today we are going to discuss tricks to solve numerical problems based on reaction enthalpy and bond enthalpy. If you want to revise the concept, you can download this mind map from my website and you can get its link in the description box. The heat of formation of Fe2O3 is minus 824.2 kJ per mole. Enthalpy change for the following reaction is, and these are the options. So what is given in the question? Heat of formation of Fe2O3 is given and we have to calculate the enthalpy change for this reaction. So first you have to write the equation for the formation of Fe2O3. And when you write the formation reaction, you have to prepare 1 mole from its constituent elements in their standard state. So Fe2O3 is formed by Fe in solid state and O2 in gaseous state. When you balance this equation, you have to keep it in your mind that you can't change anything on the product side because we are preparing just 1 mole. For balancing the equation, we can change on the reactant side. So here Fe becomes 2 and O2. Here we can write 3 by 2 to balance this equation. And the enthalpy of formation is given minus 824.2 kJ per mole. Now what is the desired equation? Find the similarity with this. So here Fe2O3 is on the reactant side, but here Fe2O3 is on product side. So we have to reverse this equation, and when you reverse this equation, you will get Fe2O3 gives 2Fe plus 3 by 2 O2. And when you reverse the equation, sign of enthalpy also will get reversed. So negative becomes positive. But still this is not the desired equation. In desired equation there are 2 moles of Fe2O3. So we have to multiply this equation by 2. When you multiply this equation, enthalpy of reaction will also get multiplied by the same factor. Now write this equation. So you will get 2 in front of Fe2O3. 2 multiplied by 2 becomes 4Fe plus 2 multiplied by 3 by 2 become 3O2. And here enthalpy will also get multiplied by 2 and you will get plus 1648.4 kJ per mole. So the option D is the right option for this question. Now come to the next question. The enthalpies of formation of N2O and NO at 298 Kelvin are 82 and 90 kJ per mole. The enthalpy of the following reaction is, and these are the options. So what is given in the question? Enthalpy of formation of N2O and NO is given. And we have to calculate the enthalpy change for this reaction. So first you have to write the equation for the formation of N2O. And when it is formed by the constituent elements in their standard state. So it will formed by N2 in gaseous state and O2 in gaseous state and you will get N2O. When you balance the equation, you have to remember you can't change anything on the product side. You have to balance the equation by changing the reactant side. So it will become 1 mole of N2 plus half mole of O2 gives NO2. And this is the enthalpy of formation is given 82 kJ per mole. Now write the equation for the formation of NO. So it will become half N2 gaseous state plus half O2 in gaseous state and you will get NO. And enthalpy of formation is given 90 kJ per mole. Now try to find the similarities in these equations with the desired equation. First we will name the equation 1 as equation 1 and it is as equation 2. Here N2O is on the reactant side while here it is on the product side. So you have to reverse this equation. We need to reverse this equation. Here NO is on the product side and here NO is already on the product side. But the problem is that here 2 NO is given and here just 1 NO. So we have to multiply this equation by 2, and when you multiply the equation, you have to multiply the enthalpy as well. So enthalpy will also get multiplied by the same factor. First, rewrite the first equation in reverse format. So it will become N2O gives N2 plus half O2. When you reverse the equation, sign of enthalpy will also get reversed. So positive becomes negative. And when you multiply the equation, you will get 2 and 2 will cancel out and you will get N2 here plus O2 gives 2NO. Now you just have to add these two equations. When you add this equation, N2 and N2 will get cancelled out. O2 will get subtracted by half O2. So you will get N2O plus half O2 gives 2NO. And when you subtract the enthalpies, you will get 98 kilojoule per mole. So the option B is the right option for this question. Now come to the next question. The enthalpies of solution of anhydrous copper sulfate and hydrated copper sulfate are minus 15.89 and 2.8 kilocalories per mole respectively. The enthalpies of hydration of copper sulfate to hydrated copper sulfate is, and these are the options. So what is given in the question? Enthalpy of solution for anhydrous copper sulfate and hydrated copper sulfate is given, and we have to calculate the enthalpy of hydration of copper sulfate to hydrated copper sulfate. So first write the desired equation. Desired equation is copper sulfate solid to copper sulfate hydrated, our desired equation. Now write the equation that is given in the question. Enthalpies of solution of anhydrous copper sulfate. When you mix solution of anything, you will get aqueous solution. So when copper sulfate solid is dissolved in water, you will get aqueous solution of copper sulfate. So here I have written copper sulfate solid and this is copper sulfate in aqueous form. So this is the enthalpy of solution and it is given minus 15.89 kilocalorie per mole. Now write the equation for the hydrated copper sulfate. So when hydrated copper sulfate in solid form, it is dissolved in water, it will become copper sulfate aqueous. So the solution enthalpy is given 2.8 kilocalorie per mole. Now find out the similarity with the desired equation. But copper sulfate hydrated is on the reactant side in the second equation. So we have to reverse this equation. So write the reverse form of the second equation. So you will get copper sulfate aqueous gives copper sulfate hydrated solid. And when you reverse the equation, sign of enthalpy will also get reversed. So plus 2.8 kilocalorie per mole becomes minus 2.8 kilocalorie per mole. Now we just have to add both equations. So write the first equation below it and it will become copper sulfate solid gives copper sulfate aqueous. Now add these equations. When you add these equations, copper sulfate aqueous will get cancelled out with copper sulfate aqueous and you will get copper sulfate solid gives copper sulfate hydrated solid. So this will be the enthalpy of hydration for the reaction. So here when you add the enthalpies, you will get minus 18.69 kilocalories per mole. So the option A is the right option for this question. Now come to the next question. The heat of formation of acetylene is, and these equations are given with their enthalpies. And these are the options. So what they have asked in the question, we have to calculate the enthalpy of formation for acetylene. So first write the equation for the formation of acetylene. So acetylene is C2H2 It is formed by its constituent elements in their standard state. That means carbon in its solid state and H2 in gaseous state. Now balance this equation, and remember you can't make any change on the product side. So when you balance this equation, you can write 2 in front of carbon. Now this equation is balanced. Now try to find out the similarities in the given equation. First we can number the equation. So this will be the equation 1, and we can name this equation 2, and this is equation 3. So now try to find out the similarities. Here carbon is on the reactant side, and here also carbon is on the reactant side. Now find out the H2. H2 here is on the reactant side. That means these two equations are fine with us. But here acetylene is on the product side, but here acetylene is on the reactant side. So we need to reverse this equation. First write the third equation in reverse format. So you will get 2CO2 plus H2 gives C2H2 plus 2.5 O2. And when you reverse the equation, enthalpy sign will also get reversed. So minus 1301 will become plus 1301 kilojoule. Now write the first and second equation below it. So here these are the equation. Now we have to add all of them. When you add all of them, find out what can get cancelled out. So here 2O2 and half O2 will become 2 and half O2. So these 2 and half O2 will get cancelled out with this 2 and half O2. So we can cancel them. Here water and water will get cancelled out. Now CO2 and 2CO2. This also will get cancelled out. So what you will get? You will get carbon plus H2 gives C2H2. And when you add these enthalpies, you will get plus 228 kilojoule. So the option D is the right option for this question. Now come to the next question. When 1000 ml of 1 molar solution of sulfuric acid is neutralized by a strong base in dilute solution, the standard enthalpy of neutralization is, and these are the options. They ask us to calculate the standard enthalpy of neutralization. And what is a standard enthalpy of neutralization? It is the enthalpy change when 1 gram equivalent of acid is completely neutralized by a base. Here H2SO4 sulfuric acid. Sulfuric acid is a diabasic acid. That means how many equivalents present in 1 molar solution? Molar mass divided by 2, we will get equivalent weight because it is a diabasic acid. So that means 1 mole is equal to 2 gram equivalents. And we know when a strong acid gets neutralized by a strong base, the enthalpy of neutralization is always minus 57.1 kilojoule. You have to remember this value. And here 2 equivalents of sulfuric acid get neutralized. So this value will get multiplied by 2 and you will get minus 114.2 kilojoule. So the option B is the right option for this question. Now come to the next question. The enthalpy of neutralization of ammonium hydroxide by HCl is minus 51.46 kilojoule per mole. Calculate the enthalpy of ionization of ammonium hydroxide. And these are the options. So what is given in the question? Enthalpy of neutralization of ammonium hydroxide by HCl is given, and we have to calculate the enthalpy of ionization for ammonium hydroxide. So first write the desired equation. This is ammonium hydroxide NH4OH. When it will get ionized, you will get NH4 plus and OH minus. So this is the desired equation. Now what do we know? We know when a strong acid neutralizes with a strong base, you will get the enthalpy of neutralization is equal to minus 51.1 kilojoule per mole. Strong acid donates H plus and a strong base donate OH minus. When they get combined, you will get water. So this equation, this neutralization reaction can be written as this equation. And for this reaction, the enthalpy of reaction will be same as the neutralization reaction. Now write down the equation of neutralization of ammonium hydroxide by HCl. So you can write this equation as NH4OH plus HCl gives NH4Cl plus water. And this is the enthalpy of neutralization that is given in the question. So when you compare these equations with the desired equation, you will easily find out that here HCl and here NH4Cl is the extra part. So we can rewrite this equation as NH4OH plus H plus gives NH4 plus water. Because HCl is a strong acid, it will give H plus, and when NH4OH reacts with H plus, you will get NH4 plus and water. For this equation, the enthalpy of neutralization is the same that is for the above equation. Now compare this equation, equation 1, and this is equation 2 with the desired equation. In the desired equation, OH minus is on the product side, but in the first equation, it is on the reactant side. So we have to reverse equation 1 and then we have to add this with the equation 2. Now write down the equation 1 below it and add it. So when you reverse the equation, enthalpy of reaction will also get reversed. So here it was minus 57.1 kilojoule per mole. So it will become plus 57.1 kilojoule per mole. Now when you add this equation, water and water will get cancelled out. Here H plus on the product side will get cancelled out with H plus on the reactant side, and you will get your desired equation. So when you add the enthalpies, you will get minus 5.64 kilojoule per mole. So the option B is the right option for this question. Now come to the next question. The enthalpy change at 25 degrees centigrade is successive breaking of OH bonds of water are. These are the equations and their respective enthalpies. The bond enthalpy of OH bond is. These are the options. What do we know about bond enthalpy? Bond enthalpy is the average bond dissociation enthalpy. So let's rewrite the equations that is given in the question. So you can rewrite water as HOH gives H and OH. So in this equation, when this first bond between oxygen and hydrogen breaks, you will get the enthalpies 498 kilojoule per mole. And when the another OH bond breaks, you will get bond enthalpy 428 kilojoule per mole. And bond enthalpy for OH is the average. So we have to take the average of these two equations. This is the equation 1 and this is the equation 2. So you have to take the average of it. So there are two equations. So when you add the enthalpies 498 with 428, you have to divide it by 2 and you will get 463 kilojoule per mole. So the option B is the right option for this question. Now come to the next question. Calculate the heat of reaction for the following equation. Given that the bond energy of C single bond C, C double bond C, C single bond H and H single bond H is 80, 145, 98 and 103 kilocalories. And these are the options. When you calculate the reaction enthalpy from the bond enthalpy, you have to subtract the summation of bond enthalpy of reactants minus summation of bond enthalpy of products. So you have to remember this formula. This formula is just opposite to that of formation enthalpy. When you calculate enthalpy of reaction in terms of enthalpy of formation, you have to subtract the enthalpy of formation of product minus summation of enthalpy of formation of reactant. So you have to remember the difference when you calculate the enthalpy of reaction in terms of enthalpy of formation or in terms of bond enthalpy. So this is the major difference that you need to remember whenever you solve numerical problems based on it. So let's try to rewrite the detailed form of the given equation. It is in this format we can write it. And for this equation, we have to calculate the enthalpy of reaction. So here, how many C single bond C, C double bond C, C single bond H. So you have to write it here. So when you calculate the enthalpy of reaction, you have to add the bond enthalpies of reactant first. So here there are 4C single bond H. So C single bond H multiplied by 4 plus C double bond C plus H single bond H. These are the enthalpies of reactant minus bond enthalpy of product. So in product there are 6 CH bonds and single C single bond C. Now place the respective bond enthalpies value that is given in the question. So here 98 is multiplied by 4 and here 98 is multiplied by 6. So when you subtract it, 4 will get cancelled out and here you will get 2. Now when you calculate it, you will get 248 minus 276. It will become minus 28 kilocalorie. So the option A is the right option for this question. I hope now you will be able to solve questions based on reaction enthalpy and bond enthalpy. But if you have any doubt or feedback, you can post them in the comment box and don't forget to like and share this video. Please subscribe to my channel and press the bell icon to get a notification. You can also join my Telegram channel or follow me on Twitter or Instagram. Thanks for watching. Keep learning. Stay safe.